Before we move on to geometry, before getting into the core, we're going to start with this topic called lines and angles. As you can see, this is the first session. So whatever figures we come across in our daily life, there are figures everywhere. For example, say you're sitting on a table right now. It can be a square shaped table or it can be a rectangular table. Okay, you might be using a laptop or you might have any other gadget or anything that you see around you. All of these have particular shapes, sizes and all. So that basically is geometry. Geometry is there everywhere around us. Now, before we start with geometry, what's the use of it? That is what we also need to understand other than the problem solving part of it. So if I go back in time, that is where geometry had originated, because earlier in civilizations, etc., there was a lot of farming, there were a lot of areas or boundaries that were marked. So guys, whenever you go to a village or go to a go somewhere outside, I mean to say the outskirts, etc., you see a lot of fencing. You see walls made up of in between which there is land enclosed. So whenever you look at such things, you see certain figures. It can be a triangular shape, it can be a rectangular shaped figure, it can be a square shaped, circular, etc., etc. So all this is basically geometry. So yeah, Bhavya, my video is off because there's a power cut at my place. So even if it's on, you cannot see anything. So once the power resumes, I will come on video. Okay. So now guys, if you can see the screen, he talks about plane geometry. Plane geometry, as the name says. Now, what's a plane? Before we move on to that, we need to understand what the word plane means. Say, you were sitting at a table, okay, or you're sitting wherever. You're sitting at a table, you have your laptop on in between. This entire area of your table, or wherever you're sitting, this is basically a plane. Any kind of area, a flat surface, is a plane. Alright? Now, he says plane geometry is all about flat figures. Now, guys, if I have to draw a cube, say I have been drawing it like this, I connect these. Now, it looks like a 3D figure, right? There's a different illusion that is created. As what it's trying to say is, you guys are sitting at a table. Okay. This is a table you're sitting on. You have your laptop or whatever placed in between. This entire area, this is basically the plane, as simple as that. Now over here, I drew a figure. Because of the way I drew it, it looks like a different figure. It is not a one-dimensional figure. It looks like a two-dimensional or a three-dimensional figure. But what are we studying on the plane geometry? He says we are studying flat figures, as simple as that. Flat figures in the sense, if I draw a circle, or if I draw something as simple as a square, or a triangle, or a rectangle, all these are basically flat figures. You can draw them on a piece of paper. Now say for example, if I have to draw a cube, what did I do? There is an illusion that was created when I drew a cube for it to look like one. Right? So that does not constitute plane geometry. If I move on to the next slide, he talks about solid geometry. Now this is what we are talking about. When you hear the word solids, even these are figures that you've come across in your daily life. For example, cubes, the one that I just drew, say something like this. Right? Or he's talking about a cylinder. When you look at a cylinder, I can only see one side of it. I can just see one face of it, but it is circular in nature. There are things around it also, right? When there's a gas cylinder that comes to your house, if you've observed, or if you've taken a Rubik's Cube or a dice in your hand whenever you played XYZ games, you see that you can see just one side at one time, or as if you change your angle of viewing, you can see other sides also. But can you see the entire cube at once? No. Right. Such figures are called solid geometry. It talks about three-dimensional objects, basically, as simple as that. Because you cannot view it from one side itself. The entire thing is not visible. If I draw a triangle, is there any other part to a triangle? No, it's just one side that I look at. If I talk about a square or if I talk about a rectangle? Do you now get the clear-cut difference between what three-dimensional figures are and what flat figures are? Is the difference between plane geometry and solid geometry clear before we move on to the next slide? Just put in a yes or a no. Okay, cool. Now, look at this word. Don't worry, it says axioms, however you want to pronounce it. But what are axioms? Can you tell me what axioms are? What do you think axioms are? You might have studied it in biology, axioms, when you were studying a plant or something.
Sir, what?
Axioms. You can see my screen, right? Axiom, however you want to pronounce it.
Oh, yes.
Right. But when we talk about geometry or when we talk about it from a mathematical point of view, there are certain facts. There are things facts are basically things that have been proved. They have been verified, right? You don't question facts because they have been proved and verified. You accept them basically. Now, if I say this is a pizza, assume that this is a pizza. Okay, 1, 2, 3, 4 slices. Now, if I say I want to take this slice out of the pizza, okay, this is a part of the pizza. Now, what are axioms? Axioms are basically the facts that we have accepted. We have assumed them to be true at all times, basically. So, if I talk about the entire pizza as a whole, I am saying that the whole is always greater than a part of the pizza. The entire pizza is always greater than one slice, whether it be 2, be it 1, be it 4 or be it 3. Because we can verify it, we can check. It is a fact that we have accepted. Clear? Now, what if I draw a line? This is a simple line, right? But guys, can you tell me what this line is made of? Did you ever question yourself saying, what is this line made up of?
Sir, they're made up of infinite points.
Great. So how did we arrive at that? Say I put one dot. This is 1 point. If I put another dot right beside it, I place the dots so close to each other that I cannot count them. That is the reason they become infinite, right? Now, if you can see, I am making a line using points, using dots. As you said, it is something that consists of infinite number of points. That is, you cannot count them, right? Now, even this, whatever I'm drawing underneath, is coming out in the form of a line, right? This is another axiom. That is, a line is made up of infinite number of points. Is it clear? Is the concept or the funda of axioms clear, guys?
Yes, sir.
Just type in yes or no. Right. But now, before we move on to these geometry products, yeah.
Is there, sir, then the one which I told, is that the only axiom?
Pardon?
Sir, now we just discussed that a line is made up of infinite points, and you said that's a proven fact or an axiom. So, are there any other axioms?
Yeah, there are so many things which are true. Say, I took the example of a pizza. One slice of the pizza is part of the entire pizza. That is something that you cannot argue upon because it's a fact. It is proven. That is, one whole is always greater than a part. When you learned about a superset and subsets. So one subset is a part of a superset. That is always true.
Yes, sir.
If I talk about natural numbers, which are denoted by n, 1, 2, 3, etc., all these are numbers which any kind of number starting from 1, all these are countable and they form a part of natural numbers, which is the superset, right? Such things, such accepted facts are when we move on from this. What's the point, guys? What is the point? A very simple term, but it has a lot of importance when we talk about geometry. What's the point? You can speak.
Sir, a point it is the two end points of a line.
He's talking about one point. He's not saying points. He's just talking about one.
Sir, a dot.
Okay, good, good. Anything else? Any other answers? Okay. So basically, guys, in the last slide, I spoke about a plane, right? It can be anything. Now, if I just go and put a dot, as simple as that, someone pointed out, that is a point. Now, does this thing have any kind of length? No. Does it have any kind of thickness? No.
No, sir. And it also does not occupy any mass.
Exactly. So that is just a point, as simple as that. If you put it in the simplest of terms, it is just a dot. Now, guys, can you tell me what is the difference between a line segment and a line?
So a line segment has a definite length, but a line both sides is infinite.
Indefinite. Okay, brilliant. Anything else?
Sir, a line doesn't have an endpoint.
One by one, guys. One by one. We're not in a hurry. Yeah.
Sir, a line doesn't have an endpoint. But
Okay.
for line segment, there are two endpoints.
Okay. 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 I've written down what you've told. Exactly. Now, guys, we assume that this screen is a plane. Okay. I have one point over here. I name it A, and then I have another point over here and B. And say I connect these two points. As simple as that. From A to B. For example, I say that this is 5 centimeters. Now, AB becomes line segment. How do I represent it? I put AB and I put a bar on top of it. This is a line segment. As you guys have told me,
Sir,
it has two endpoints. A and B. Yeah.
Sir, a bar with, if you have to represent a line segment, then you have to put a bar and two dots on the both sides.
You talking about this?
Sir, can you hear me?
Yeah, I can hear you. So what I'm saying is when you're representing a line segment, you put a bar on top. But when you're talking about a line, you do not. Because as you guys have told me, a line is indefinite. It does not have an endpoint. Now, if you look at this figure over here, we had A and B, but we did not have two definite endpoints. The line was extending indefinitely on both. Look at this arrow. It talks about the line going on continuously, and even to the left hand side of A, it's going on continuously. This is basically a line, but this is a line segment. Is this very clear? Now, when we talk about geometry, we talk about the angles, about lines, and we talk about angles. Now, how do I form an angle? Okay.
Can I?
Using a protractor.
Right. So what do we say? The sun rays is the term that we use. Sun rays. Now, the sun is the point from which the rays originate, right? Assuming the sun to be a point and assuming one ray. What is this? From one point A. Say I name this point A. Originate
Sir, it has a
source of
fixed
light.
point.
Correct. One point is fixed and it extends indefinitely, right? When light originates from the sun, guys, it extends indefinitely till it hits the earth, right? That is the reason we call it a ray. Is this very clear? If you're not speaking, please be on mute. If you want to speak, you can unmute yourself. Are these four terms clear? Point,
Yes,
line, and ray. Very clear?
Yes.
Sure.